Welcome to part 6. Thank you.
Welcome guys. As you can see, our inverter is turning into an inverter gradually. This is the DC fan. This is the H bridge. It has been connected to the transformer. Like I said, this is where battery minus will come in, and this is where battery negative will come in. Then I mentioned the H bridge signals. The signal that will activate the A bridge. I've connected these wires, so these wires will be connected to the MOSFET driver board. I think it will be like this in the casing. It will be like this, so I'll connect them to the MOSFET driver board. At this moment, I will test the fan. I have a 12-volt battery here. This is a 12-volt DC fan. So let me try to test the fan and see how it's going to work. So I'll just connect the 12-volt battery to the fan. As you can see, the fan is spinning already. At this moment, it is spinning at its maximum speed, but when it is being controlled by the main control board, the main control board can dictate the speed. But now I'm just connecting it directly to a battery for a testing purpose. So the function is to cool down the MOSFET. There will be a temperature sensor at this point. So the inverter is turning into a machine gradually. Thank you. I'm going to connect the communication line here. I'm going to solder this cable. I'm going to solder it to this point. That is for our LCD. Yeah, the soldering is completed. The next thing I'm going to do is I'm going to put hot gun on this place so that pressure will not pull the cable out. I'm going to put hot. This gum is just to hold it down. It's not doing any electrical or electronics job. It's just to hold down the cable so that it won't pull out under tension. That's the job. Soldering is done and the glue is applied. I'll leave it for some time so that the glue could dry up. Okay guys, let us talk about the board for a brief moment. This is where I will connect the DC battery in 12 volts. In this case, this is RC, it means relay control. The RC is also on the changeover board, so the relay control on the main board will be connected to the relay control on the changeover board, and the LCD, this slot is for the LCD display. This is TS, that is where temperature sensor will be connected. This is CS, that is current sensor, that's where current sensor will be connected. And this is driver power. The MOSFET driver board needs power, so this is where it will get its power. This is what I mean, driver power, that's where we connect it. The MOSFET driver board also needs the signal. This is driver signal, and it will be from here, so driver signal. This is the fan, where the DC fan will be connected. The DC fan was connected to the battery during test, but during real inverter operation it will be connected here, such that when the inverter is slightly hot, the fan will start up at half of its speed to cool it down. But if the temperature is higher than a preset value, the fan goes to maximum speed, so the speed is controllable from this place. And another point here is the AC sense. This is where the inverter uses to sense NEPA, so that when NEPA comes in, the inverter will know that there is NEPA, so it will switch over automatically. So this is the AC sense on the driver board, and this is the feedback for the feedback transformer. The feedback at this point is the feedback from the feedback transformer, so 12 volts will be supplied to this place by the feedback transformer. Thank you. After connecting the filter capacitor and the feedback transformer, the next thing is to connect the main control board. So this is where the main control board will be, and I'm going to use bolt and nut to connect it. So that is the main control board entering into the inverter box. I've connected the main control board, and I've applied the bolt and nut. So the next thing is for me to connect the changeover board. It will be positioned here, and I also use bolt and nut to hold it down. All these connections, I've explained them. This is the feedback connection. This feedback from the transformer, this feedback, the 220 volt side, will be connected to the feedback here. The relay control from the main control board, like I've explained when I was explaining the board, will come into the relay control. It will be like this. So the filter capacitor will come into this place, and the neutral for the AC will be here. So this is what I'll do next. Fix the AC changeover board. Still on the changeover board, I've made some electrical wiring on the changeover board to the relay board. So what I've done is to be able to pass some of this cable to the inverter output, and then some of the cables will go to the inverter transformer. So this is still the changeover board. I'll position it here like I said. This is the main board, changeover board. I'll position it where it should be. Thank you. Still on the changeover board, I've made some electrical wiring on the changeover board to the relay board. So what I've done is to be able to pass some of this cable to the inverter output, and then some of the cables will go to the inverter transformer. So this is still the changeover board. I'll position it here like I said. This is the main board, changeover board. I'll position it where it should be. Thank you. Yes, I've made the changeover board connection You can see the changeover board. Some of the cables are passed to this other side. That is where we feed AC into the inverter, and we can have AC out of the inverter. So these two are going to the transformer. This is the neutral of the transformer, and this is the output of the transformer. So these two cables will feed the transformer, and we have 4 cables feeding, 2 feeding the load, 2 feeding the load, and 2 supplying AC to the inverter. This is the AC connector. It has been connected properly. All the 4 cables have been properly connected into the sockets. So don't forget, we're still on the changeover board. I've included some sleeves to protect the cable from touching the inverter casing. So that's the AC connection.
To be continued in part 7.